Okay, a very good day to our lecturers, Mr. Tiang. My name is Mohammad Syaaban bin Nordin. My metric number is 18109125 from RK23 Electrical System Engineering. Okay, now I will explain to you about previous our project, which is parameter measurement and active power of three-phase system. Okay, we go to introduction first. A three-phase system is balanced if a load of each phase has equal impedance value, a load impedance of each phase has equal phase angle, voltage and current value are equal for each phase, and phase displacement is 120 degree between each phase. Okay, in this case of balanced three-phase system, the current does not flow through a common straight line. Okay, in general, three-phase systems are preferred over single-phase system for the transmission of power for many reasons, including the following. Single conductor can be used to transmit the same kilovolt per ampere at the same voltage. We reduce the amount of copper required, typically about 25% less, and in turn reduce construction and maintenance costs. Okay, for the second is the lighter lines are easier to install and the supporting structure can be less massive and further apart. Okay, third is three-phase equipment and motor have prefer running and starting characteristic compared to single-phase system because of a more even flow of power to the transducer that can be delivered by a single-phase supply. For most larger motor are three-phase because they are essentially self-starting and do not require a special design or additional starting circuit. From this diagram, it shows that three-phase system angle between the three phase is 120 degree. So it divide 120 equal to 360. So this is the sinusoidal signal which has three, the black, blue and the red. Okay, moreover, the three-phase system has four wires, which is the three current carrying conductor and the one is neutral. The cross-section area of the neutral conductor is half of the live wire. Okay, the current in the neutral wire is equal to the sum of the line current of the three-phase wire and consequently equal to 3 times the zero-phase sequence component of current. Okay, in this project, as an electrical engineer, we are given the task to investigate and analyze the electrical system based on standard to a local electrical supply authority, which is TNB in our country, Malaysia. Okay, so we are referred to the latest updated electrical supply application handbook V3 ISA provided by TNB. In this project, we use system that consists of a three-phase well-connected generator, transmission loose, and a load with acceptance power factor lagging of 0.9 according to ISA V3 for voltage level 1 to 3 kV and above. Okay, this is the ISA. So this is the module. Okay, it says that our supply frequency in Malaysia is 50 Hz and 0.9 for voltage level for 132 kV and above. Okay, and then okay, objective. Okay, the objective of this project is to make the student familiarize with our local standard electrical based on electrical supply authority, to investigate and analyze the three-phase system parameter, and to evaluate the active power absorbed by the loads by using two wattmeter methods and the conventional measuring method. Okay, and then we go to methodology. Okay, every student will be randomly assigned the line-to-line rate voltage of the generator. From the appendix, I get V line to line is 275 kV. So the V phase was measured by applying the formula V phase equal to voltage line to line over Z3. Okay, and then we get the impedance value from this method, which is from our metric number. So you can see here, transmission loss equal to D and C for load A and B. So for my metric number equal to 55 ohm plus 12 J omega for transmission loads and 81 ohm plus 9 J omega for loads. Okay, then uh, step 3 is construct a real circuit by applying the impedance and voltage line to line that's given to me in the appendix. So this is my circuit that I draw in eDraw. So from the question it says that it's Y to Y connected. So from my metric number, this is my impedance value at the line at the line 55 plus J12 and 81 plus J9 at the load. So line to line voltage given is 275 kilovolt. So using the formula, I got 158.67 kilovolt. And then step 4, the voltage drop percentage is measured by applying this formula that was given in the appendix. And then calculate the total power delivered to the load by using the conventional method and 2 wattmeter method. And then the circuit was constructed in PC to justify my calculation. And the normal operating condition is justified. This is my simple workflow for this project. Project assigned by the lecturer. Find all the parameters, draw a solution on PC, get all the result calculation, and we compare with PC. So later we see and did education with the result achieved, and then we submit the report to be evaluated by the lecturer. Okay, and then we go to part 3, which is result and discussion. So this is my circuit on PC. So you can see here there is a 3 wire which is in Y connection. So it is a generator and it is load. So you can see here there is also Y. So this wire for the neutral. Line to line voltage given is 275 kilovolt. So the V phase on each circuit is equal to, using this formula, V phase equal to voltage line to line over circuit 3. For V phase we get 158 kilovolt, and then we also get the V phase which is almost same to the previous value. Okay, and then we calculate the I line which is we using the formula V over Z load plus Z line equal to 1153.753. Okay, what difference between IA, IB and IC is only for the angle. So this angle, see, since IL equal to I phase, we get the I phase value. Same with I load, and then we calculate the V phase load, V phase for load. So from the I phase, we times with Z at the load. So ZA, ZB, and ZC. So we get the value 94.03 kilovolt, and three V phase for 3 load is same but different in angle. And then okay, and then we calculate the V drop using this formula. V drop equal to V supply minus V load over V supply times 100. And for my case, I get 40.67%. Okay, and then we find the voltage line to line at the load on each leg of the load. Okay, we must aware about this because voltage line to line at the load not same with voltage line to line at the generator. So we calculate using the formula set 3 times V phase at load. So V phase load at A, V phase load B, and V phase load C. Okay, the answer is the same. The magnitude is the same but different in angle. So the A, the B, and for the C. And then we using wattmeter method. From we refer to the ISAF V3 for the PF value. It states that power factor lagging 0.9 for voltage level 132 kilovolt and above. So cos inverse 0.9 equal to 25.8491. So this is formula for wattmeter 1, wattmeter 2 for Y to Y connection. So we get this value to value wattmeter 1 and wattmeter 2, and then we add up. Okay, from the figure seen above, I did a simulation on PC. So real power for the IA vs VAB is 1.5166 times to the 10 to the power of 8, and the real power for the IB vs VCB is 1.6836 times 10 to the power of 8. And then we add up between for these two value, P1 plus P2, and when we get the value, and then we can compare between three value from the simulation, wattmeter method, and conventional method. Okay, discussion. Figure 4 show the simulation result for the line current. Okay, for the Y to Y connection, the line current is same to phase current. When we compare to the measure value, it's only slightly different from measure value in PC simulation. Next, to get the V phase, we need to times with I phase load, which is same to I line. In this project, we try to get and compare the active power absorbed by the load, and we use three methods to evaluate the power, which is wattmeter method, conventional method, and did in simulation and we did a simulation on PC. The figure 6 show the simulation result to get the real power. We got the almost the same value to each other. From the wattmeter method, I got 300 megawatt. Conventional method 322 megawatt, and we run on a simulation and got 320 megawatt. Besides that, we also calculate the voltage drop is percentage. The value is too high, which is 40.77%. It means it has exceed the acceptable voltage drop based on standard British BS7671 or any Malaysian industry standard. Okay, part 5 conclusion. In conclusion, in this experiment, our objective is accomplished. We have familiarized enough with our local standard electrical system based on local electrical supply authority. Besides, we achieve the next objective, which is able to evaluate, investigate, and analyze the three-phase system parameter. Normally, the operation of three-phase system in ideal condition and balance in three-phase condition. Lastly, we are able to evaluate the active power absorbed by the load by using wattmeter method and the conventional measuring method, although both method has slightly difference. And then this is my reference on this project. So this is a link for get the ISAH book from TNB. So this is wattmeter method that I use, and this for theory. Okay, that's all from me. Thank you.